Good evening, everyone. I've been seriously looking forward to tonight's stream. I've just been explaining in the chat that, again, audio levels. Actually, this is blasting my ears now. Ugh. Audio levels will be the death of me. How am I going to fix this? Let's turn that down a bit. Let me know if the music volume should go up. I'm guessing it should probably go up. But the other night was quite a late night. We were having a look at the Smashtastic binary. I'm very reticent to call it a binary since Blue Pill put me onto it. It's part of the UNSW CTF challenge, and what was weird about it was they only give out source code. Thanks, Blue Pill. They only give out source code for this challenge, so we had to build it ourselves according to what they said the situation on the server was. And they said it was a 64-bit binary, which we determined to be almost certainly a lie. But we had to try to match our compiler settings to their compiler settings, and even then, there's no guarantees that any two compilers, given any two different phases of the moon during which they were used, will generate the same binary, based on things like optimization, based on things like how any given compiler decides to work. So we were given source code, which we've got a copy of. I should probably have set all this up earlier, actually. Smashtastic. We're given source code, and we compiled it, and we got a few bugs out of it. We were able to basically develop an exploit that would provide an API to a info leak. We were able to use a write what offset at a certain offset on the stack. So we can use that to basically trod right up and down the stack and write any sort of D word anywhere on the stack. We found the format string bug was what gave us the info leak API. And towards the end, I kind of glossed over this, but I also found a way to basically put a string somewhere on the stack that then, this music's still too loud for my headphones. Let's see how that is. Which would be important for anything like any sort of ret to libc tactic. Let's see if that gets rid of Monster Cat. There we go. So we ended up with a bit of a hurdle, and that hurdle was we were trying to use PwnTools. PwnTools' DynElf function. PwnTools documentation. PwnTools gives us something called DynElf, which is a hammer I found a couple of months ago, and since then everything has been a nail that I've tried to whack with this function. What this function does is, given a Python function which implements an info leak and presents an API, kind of like this, you have to define a function that takes an address and then returns some stream of bytes leaked from that address on the target system. If you give it that, and for example, a pointer anywhere into the binary image that's been loaded up onto the remote system, DynElf will automatically basically walk up and down memory of the binary, even if it doesn't know exactly what the binary running on the remote system is, which in our case is the case. We don't know exactly what binary image is loaded on the target. It will walk up and down that binary image. It'll find something like, maybe, I think it uses the GOT, and it uses that to find a pointer into libc, and then it starts walking up and down libc, and will discover and return to you the address of any libc function. In this case, we want to do a ret to libc attack, so we want to find the address of system. So I was trying to use this function to do that, and the issue that I was having, let's see if I can diagram this up a bit. The issue I was having is memory looks like this: OX FF OX 00000000. Roughly, memory looks kind of like this. And the binary was mapped roughly at work, Smashtastic. Let's just go and GDB it. Okay, so this is where on our machine the main function is. VM map. Whereas the actual binary is at this address here. That'll do. Let's put a 0 there. It's actually, I was expecting that to end in a null. But anyway, what DINELF was doing was it was trying to walk the pages. Actually, that's right. The page will be on ending in a null address, but the actual binary starts 40 bytes or 440 bytes into that page. What DINELF was doing was it was basically, we were giving it a pointer to main, let's say, and we were getting it to walk all of this. Actually, let's see if we can find out where the binary finishes. About there. Binary image top address. I don't know what you'd actually call the non-base address, but the opposite. So you can see that the binary is mapped between 8440 and 9CAC, and DINELF was walking this entire range trying to learn more about the binary. And what it was doing, I believe, is walking backwards until it found the ELF header, like the actual binary image signature, XXD, Smashtastic, pumped into less. We're looking for this, hex 7F, ELF. In memory, and it was walking backwards till it could see that. And what we were doing, let's actually open the Smashtastic exploit. The leak function that we wrote looked a lot like this. It looked exactly like this. We were having to, because it's a leak based on a vulnerable string printing function with a format string bug, we knew that we couldn't send any data that had a null byte or else it would terminate our string. So what we were doing, this is what you're supposed to do, is you're supposed to check if the target, represented as a little endian pointer, contains the null byte. And if it does contain the null byte, then you need to return none. So that DINELF, as a consumer of this leak function, can go, oh, the leak function gave me back the special Python value, none. It's probably because I asked it to leak something with a null byte in it. What I'm going to do as DINELF is I'm going to ask that function to leak from the address I wanted, -1, and whatever I get back, I'll just throw away the first byte and consider that to be what I wanted in the first place. The issue being, it was, let's, 8000 binary image page base address, because this is where the page starts, the binary image got mapped into. When it was trying to leak this here, because it has this null byte in it, we were kicking back none to say, no, you're not allowed to leak something with a null in it. And PwnTools was going, oh, okay, right, what I'll do is I'll leak 0x08 04 8 7 FFF. And I'll subtract 1 from it and then leak from that on, then I'll just chuck away the first byte. The issue being that this is an unmapped address, because the page that contains the binary image starts here and goes all the way through here, and this is an illegal address, and so we would get a out of bounds read, we'd get an illegal read, and it would crash. So that's where we left off, and then I kind of ended up going, oh, maybe an NX is not on the target, let's just assume it's off, and I tried that, and that didn't work. Is the music super quiet? I'm going to turn it up and you can yell at me if it's too loud. Where's the monitor? Okay, I've turned that up a whole bunch now. Let me know how it goes. Actually, you know what, I'll turn it a bit more. You're in the YOLO once. So, we were walking backwards off this page and crashing on this, and then I thought, oh, maybe we'll just assume dep is off. It's a quiet part of the music, so I don't start judging it just yet. And then I thought, towards the end I was thinking, oh, we're going to have to manually do DINELF's job for it. We're going to need to find our own pointer into libc, do our own leaking of it, try and find a build ID, try and find out what operating system it is, go and download libc, and then from there we can probably start to actually discover offsets ourselves, which would have sucked. Since then, I did some Googling and found a really neat trick that would actually let us work around this issue. It's a really neat hack. And I then produced my own binary that operates similarly to Smashtastic, but it's not exactly Smashtastic, so I wanted to save Smashtastic for the stream. I labbed it up and I got it to work. So tonight, I'm going to start off going through my DynElf punching bag. I'll explain how it works, we'll exploit this, and then we'll see if we can transpose that across to Smashtastic. And this will also give an opportunity to better explain as we go how InfoLeaks work, how ret2libc works, and how DynElf works. Maybe. We'll see how rushed and frantic I end up getting, because I really want to exploit this tonight, and I really want to exploit Smashtastic tonight. So having a look at dynelf.c. I haven't decided what I'm going to do with this code. I might publish it later. If I don't end up publishing it, but you want a copy, hit me up and I'll get you a copy. So what this does, what this program does, is I've just got a whole bunch of variables everywhere. This pwnable leaks more than it needs to, but we can selectively pick and choose what leaks we want to make use of, and treat it like a punching bag. You know, we can do whatever exercise we want based on this super easy pwnable. So the first thing it does is inside main, it declares just a static stack variable, which I don't end up using. It declares a non-static 256 byte long stack variable, which I do end up using. It initializes it to some string, and spoiler alert, we get to do a stack buffer overflow on this later on. The next thing I do is I go and get some pointers out of libc. So I call them libc system and libc exit. I end up using neither of these, but they're there if you want to practice some different stuff. What I do is I use dlsim to basically resolve the address of the system function and the exit function within libc itself. All I do is I then assign the results of these to some variables that I can then refer to later on. I then unbuffer my stdout so that when you connect to it remotely or when you connect to it using pwnTools, you don't have output buffering issues. You get all the bytes you want. Then what I do is kick off an infinite loop and I smash out a menu. So I smash out a menu each time you actually repeat this loop. And so the menu explains basically the API, the functions you can call that this binary provides. What I then do is I ask for a choice. I ask for a integer from stdin, saying, hey, give me a number. And obviously it's going to be one of these 4 numbers here. Ignore the ifdef debug because the debug mode is off. What I then do is, based on the choice that the person made, how's those audio levels? It's good now? Cool. Based on the choice that the user makes, I do one of several things based on the options I provided in the menu. If you pick number 1, leak pointers, behind door number 1, it just spits out some JSON. And that JSON has unsigned integers, just normal numbers, not hexadecimal, because JSON doesn't let you use hex. I just smash out some JSON with a whole bunch of pointers. I hand away a pointer into main. I hand away a pointer to the static stack variable, which I don't end up using. I give away a pointer to the stack variable, which I do end up using. I give away a pointer to some global variables, which I don't end up using. I give away a pointer to system inside libc, which I don't end up using. And I give away a pointer to exit inside libc, which I don't end up using, but they're there if the need arises in the future. So you know what, we might use this system one, just do a really simple ret2libc, and then we'll do the tricky way. If you ask for option number 2, then I call the leak function. And so the leak function, what it does is just prints out a prompt. It asks for a integer, on an unsigned integer on standard in, just pulls in a number. Ignore the ifdef debug, and then what it does is it prints out a hex, a 0 padded, without the 0x on front, hex representation of the length of what it's about to leak, and that just makes picking it up off the wire a lot easier. It's a length value encoding. So I spit out the length of what you're about to leak, and then I spit out as a string of bytes whatever is at the pointer that was accepted on stdin. So what you can do is you can consume this leak API. It's basically a much friendlier version of the format string bug that is implemented in Smashtastic. All it does is ask for a pointer and then goes, okay, cool, there are X number of bytes that I'm about to leak you, here they are. And it just lets you leak arbitrary memory. Of course, if the consumer asks for an illegal address like deadbeef for 41414141, you'll get a crash, but otherwise it will just spit back the link to what it's about to leak and then leak some bytes. So it gives you a super easy to consume info leak API. Third option is to read into stack variables. So this variable here, this 256 byte buffer, if you pick option 3, I just gets straight into it, which is just straight up stack buffer overflow. Option number 4 is I just do a return, because option number 4 is to return, so that will trigger a save return pointer, a return to the save return, a return to the overwritten save return pointer. If you suck at giving responses to a menu, I tell you that that's a bad choice because you gave a number that doesn't make sense, and that's all the program really does. It is compiled with, what did I do it as? NX on, ASLR on, the stack canary is off. So the stack buffer overflow is super easy to exploit. You can just smash out a whole bunch of A's. The fact that NX and ASLR are both on makes the traditional way of exploiting it a bit tricky. With this binary, you can't just smash the save return pointer and then point it to some shellcode and have it return to it and off it goes. Nor can you, because ASLR's on, if you found a jump ESP gadget, it's like, yeah, well done. I mean, unless you use the info leak to find out. Well, I mean, there is an info leak in this thing, so you could use it. But NX is on, so you can't just execute shellcode on the stack anyway. So that's what it is. And the way we're going to overcome this NX is to use a technique called ret to libc. So ret to libc means that we're going to smash the save return pointer with the address of a function inside libc. So when it does a return, it's going to return to libc, hence the name. The trick is with a return to libc exploit, what you need to do is you need to pretend that you weren't returning into a function libc, you've got to pretend you were calling it. Which is easy to do because, as we know, when you call a function, it pushes, first of all, you push your arguments to the stack on x86, and then the call will push a save return pointer. So you can just make sure you follow up the save return pointer overwrite with some junk pointer, which will be the save return pointer that the libc function will then return to. In the case of system, it doesn't return, so that can just be junk, be it ZZZZ, whatever we want. And then we can just kind of line up on the stack all the function parameters, because it's a stack return, it's a stack buffer overflow. We can just go and write out as many A's as we need, the pointer to the libc function, some junk pointer, and then the first argument to system, which in this case is a char star for system. We just need a pointer to a string in memory, which will be the command we want to execute, which will just be bin sh or even just sh, and away we go. We've got a shell. So what we'll do is we will relatively quickly exploit this. So I've got an exploit for it already, but I'm going to recreate it from scratch so we can kind of see the process. So I'll call it dinelf exploit.py. The usual rules apply, or guidelines apply. If you need my attention in chat, please use my name. Otherwise, I'm going to get straight into this because there's a lot to get through tonight. User bin python use bin env python 2 import pwn. So my phone's not on silent. Cool, that worked. T equals pwn.process. So we'll start the binary up as a process. GDB pwn.gdb.attach. So we'll create this GDB CMD string. Cool, so this will start off as just being, hey, continue, then we'll go t.interactive, Let's see if that works. Nope, it's not going to work because I forgot to set the pwn context to kick off tmux splits. Pwn.context.update terminal tmux split w. Cool. So we've got the process starting up here, and here's GDB. So for example, if we were to pick number 1, leak pointers, gives us back a bunch of JSON, and these pointers here are integer representations of addresses inside the program. So for example, we know that the stack variable should have the string stack var contents in it. So what we'll do is we know that the address of stack var goes over 2 lines. So if we break in GDB and we examine one string at that address, there we go. We've got stack var contents. So this here is actually a faithful integer representation of a pointer to a string variable on the stack. Actually, it's a stack variable. So this here is the stack, as opposed to, and this here is the hex of that there, as opposed to the static stack var content. Actually, let's go the global variable contents. Global var is this here. In GDB, if we do examine one string there, then we get global var contents. We can see this here is a pointer. Yeah, this looks like a stack pointer. We can see that stack addresses look like FFD2, that makes sense. Whereas this here will be a pointer inside the actual binary. We do a VM map. Oh, did I just trigger the pwn_tools bug that? That sucks. Really, is my pwn_tools that out of date? That bug got fixed ages ago. Alright, let's install that and see if that fixes that. Yeah, there was a bug a while ago in pwn_tools where if you maximized the pane that was running GDB, you'd get an awful crash. Or maybe I've just discovered a weird and wonderful new way to trigger it. We'll see. Oh, that sucks. So we'll go leak pointers. Here are the pointers here. If we do an arbitrary leak, then we could do number 2 to leak something at this address here. Actually, let's go to the stack variable address. So if we leak at that address there, we get this back here. We get an 8-character long hex representation of the length of this string, which just makes it easier for us to consume. We don't need to go and parse and try and see if the menus come up already and blah blah blah. And then we get the data at that address, which if it's null terminated, it'll stop reading at that null byte, which is stack var contents. That's what we expect to see from the stack var, because the stack var contains stack var contents. Option number 3, read into the stack variable. Hello Twitch. Cool, that's done. Now if we do that arbitrary leak again, and if we leak this same pointer, we now get hello Twitch with a different length. And then we can cause a return, which causes the program to wind up. And that's still going. Oh, did I do -- user? Nope. Start that again. Brrr. Alright, let's see how that goes. That's the program in a nutshell. Simple stuff. We can do things like trigger that stack buffer overflow with t.sendLine a times 1024. Oops, nope. If we just send it straight to the menu, it's going to do nothing. So we want to go t.sendLine number 3 to do the gets into the buffer. We want to send that, and then we want to send number 4 to cause the return to happen. There we go. Crash at 41414141. But we wouldn't be able to have a look at, like, oh, we can go, yeah, EBX points, no, ESP points towards our A's. You know, we could do a jump call ESP, and there's none there. But even if there was one there, we got NX, which would totally kill that attempt anyway. So now we want to set up some sort of, you know, ret to libc sort of attack. Does streaming on Twitch help your program? Sort of, yeah, it sort of does. I've made mistakes before that if it weren't for being able to rubber duck on Twitch would totally have had me stunned for hours. So yeah, it has helped in the past with some rubber ducking. Good to have you, Waterat. Hopefully you enjoy what you see here. If not, then that's totally cool. We're doing some binary exploitation tonight. So that's triggering that bug. So we want to use some sort of ret to libc attack to overcome NX. So what we want to do is we want to write some code that will actually trigger option number 1 and then make sense of these pointers that were leaked. So what we'll do is we'll get rid of that. First thing I'll do is come up with a function that will basically just eat everything that's in the pipeline up until it gets to a caret space, which will basically be able to eat menus, eat prompts, and just get rid of all the garbage. So we're going to go t.recv until angle bracket space, and we'll just return it in case someone cares to actually get a copy of it. So we'll eat the prompt, which will also eat the menu. Now we want to write a function that will trigger menu item number 2. We'll read this in and we'll decode the JSON. So let's def leak pointers, return to t.sendLine. We'll assume for all these functions that the prompt has already been eaten, and we'll make sure that the functions eat the prompt when they're done. So we'll send number 1, which has the effect of going 1 enter, and the very next thing that comes back is the JSON. So pointers equals t.recv line, and then we want to eat the prompt and return the pointers. So in that case, if we were to do print, or let's go pointers equals leak pointers, and then phone.log.success pointers, and just print them out, then what we'll get is this. It tells us that it leaked the pointers, and Python can actually see this and make sense of it. But this is totally useless because that's actually JSON. You know, why don't we actually get the leak pointers function to parse it and return the guts of it as, you know, something meaningful instead of just a nonsense ASCII string. To do that, I think we just do import JSON, JSON.load string, I think it is. Yeah, so if we do this, we get back what looks like a dictionary. And then we can, you know, index into that and go capital A, and we get back the 1337. So we'll do pointers equals json.loadString on that there, and we'll return those pointers. We'll add some logging. Let's see how that goes. Oop. Got to import JSON. There we go. This actually looks like it is seeing it now as a dictionary. So what we can do is we can call this function here and you actually get the pointers, and then we can do, for example, print hex. We'll hex encode it just so it makes it easier to look up. Print hex pointers. Let's go and have a look at the main pointer. So we run. Oops, no, it's unhappy about something. I don't know why I put that there. Main. There we go. So it's actually, we can use stuff like this here and actually index into that pointers dictionary and pluck out pointers we're interested in. And we can then hex encode them, print them out, and it looks like this. And if we copy that, we break in GDB and go examine one instruction at that address. Don't know what GDB did there. I must have copied a carriage return or something. Accidentally. X1i, there we go. We can see that that is actually a pointer to the main function. And if we was to run this again, we'd get a different pointer. Is that a different pointer? Yeah, it's a different pointer because ASLR moves that main function around. So now we can reliably get any of these pointers and actually index into them and use the contents. So that's made use of that. Now if we're going to do let's just use the fact that, let's get rid of main, go system. So here we get a different address. It'll be the address of system. If we break in GDB, examine one instruction, then it's the system inside, it's the libc system function. Don't know if you heard that, but the dog's getting in trouble. So let's start on easy mode. Let's set up this whole ret to libc shenanigans using the fact that, the program leaks a bajillion pointers. Let's actually make use of this system pointer, and then we'll get to the stage where we don't need to even use that, where we can just use a pointer inside the actual binary, inside the actual process. So let's not print that anymore. Actually, let's not do it anymore at all. Let's trigger this stack buffer overflow and make some use of it. What are we going to do? T dot. Let's define a function. Yeah, so we'll define a function called stack buffer overflow, and it'll take a buff. So it's going to explain what it's doing. Trigger XPO with payload of length. So I'll just explain that it's triggering with a payload of length whatever. We should actually refer to that. We're going to t.sendLine. That's what I want on the menu. We're going to t.sendLine. We're going to send number 3, so we can actually perform the stack buffer overflow. T.sendLine buff. We should actually add some sanity check into this function. If space in buff, or actually no, we want new line there, don't we? Or null byte in buff. because we know it's using gets. The vulnerable function is gets, and gets will, I think gets will terminate on new line. Yeah, it reads a line. Maybe nulls are okay for gets. One way to check. Actually, what we'll do is we'll just comment this out. We'll do bad character checks in a second. So we're going to trigger the SBO, send number 3, send the buff, t.send line number 4. And that's really all we need to do. We don't, what should we eat the prompt? Yeah, we'll eat that prompt there. That should do the trick. So now if we go and SBO with a length of 1024, we should get a crash. There we go, we get a crash. Now can we send 1024 nulls? Yeah, we can send nulls, there you go. So gets does take nulls, it just doesn't take new line. So if new line in buff, print, let's not print, let's pwn.log.error, because that'll actually throw an exception for us. Yep, cool. So now we can go buff is empty, buff plus equals pwn.cyclic 1024. And then we just SBO with buff. And here we go. This here is, we've obviously got our cyclic patterns sprayed all through the stack. We can grab this to find the offset. So we'll copy that. Instead of this here, we'll do buff plus equals a times pwn.cyclic find. Buff plus equals BBBB. Buff plus equals a couple of C's. Buff plus equals DDDD. Let's do one more. So we send that off. And here we go. We've got this in here is indeed our SRP override. We can see that we tried to return to BBBB, and we can see that on the stack we've got CCCC, DDDD, EEEE. So these then come after it on the stack. One more thing, because we're about to do, so you know what, we'll do that in a second. So now what we can do, instead of BBBB, we can do pwn.p32 pointers system. Because up here, remember, we actually populated pointers with a dictionary full of pointers, and one of them is the pointer to system. So we can just go and do a return to libc by smashing the save return pointer and setting it to system. We know when we do that, that this here will be a fake save return pointer for the call as per above, for the faked call. Because when this here gets returned to, the stack will slide down a pointer and point to here, and then this will be considered the save return pointer that this would have put on the stack had it been a call. So this is a bit of dead space here. Then this here is arg1, so this here is going to be system, arg1 is going to be that there. So it's got to be a char star, it's got to be a pointer to the string, which is a string of the program we want to run. Just check. And so we need to find a way to put the string bin shell in memory so we can point to it, which we'll do in a second. Let's just check to see if this this whole ret to libc thing is making sense. we'll add to our GDB commands a break on system. So we'll break when the system function gets called, and send that off. And here we go, breakpoint 1 got hit, the system function was being executed, and the stack looks like this. Here's our fake save return pointer, and then here would be our first argument, which contains 44444444. Yeah, we can see the system is being executed. We can see that the function preamble is here, and it's probably about to try and execute the command line, which will be the string at 4444 blah blah blah. So if we have a look at which string that is, there is nothing there. There's nothing at DDDD. So if we continue, we're probably going to see an illegal read of 4444 and a crash when the system function tries to find out, well, what should I be executing? If we continue, no, didn't crash, it just didn't make much sense. Huh, would have thought that we would have seen a crash there. Let's try something real quick. We've got to actually follow the fork to the child. Nope, still didn't get a crash. Oh well. So now the last thing we need to do is put the string bin shell null terminated in memory somewhere, and then put the pointer to that here. In terms of places to put that string, if we look at the pointers that get leaked, we actually get given a pointer to the stack variable, which we are currently overflowing. So at the address that got leaked to us for stack variable, there will be a bunch of A's, some C's, some D's, a pointer, whatever. What if we just put the string bin shell at the beginning of all those A's, and then just use our leaked pointer to stack var here for the arg1 for the char star? Seems like it should work. So what we'll do is we'll go buff plus equals bin shell null byte. We'll adjust this here to compensate for the extra bit of length here. Instead of the D's, we don't need the E's anymore. Instead of the D's, we'll do pwn.p32 pointers stack var. And we will run that, and we should get a shell. Yep, there we go. New program being executed, bin dash. If we come up here, and we've got a shell. So this is what ret to libc looks like. What you do is you go and perform a stack buffer overflow. You overwrite the save return pointer with a pointer to the system function inside libc, which helpfully this leak pointers Bizzo was kind enough to give to us. We don't have this luxury on Smashtastic, but we know how we can get there using dinelf. And then what you do is you just throw a fake save return pointer to compensate for the fact that had it been a real call to system, then there'd be a real save return pointer here. The neat thing is system doesn't return. Oh, it does too. Yeah, because it forks. Ah well, we'll just let the process crash and burn when it tries to return to that address there. In fact, if we exit this shell, okay, whatever. So here's a fake save return pointer, and then we put a pointer to the string bin shell, which we've put on the stack, and we've used the leaked pointer to stack var to actually manage that. So now the next question is, and this is going to start to more closely simulate Smashtastic, What if we weren't given a pointer to system? What would we do? Well, what we could do is we could look at what other pointers we do get. We could given a pointer inside the binary, which is actually pretty closely simulating what Smashtastic does, because we were able to leak some of the stack and get a pointer inside the binary. We've got some variables. We've got system itself, which we're going to ban ourselves from using, and we get exit. So let's actually go pointers system equals 0. Not allowed to use it anymore. Let's pretend that we didn't get this system pointer. We also get libc's exit. So the next logical step would be to, we're going to skip this step, we're going to skip right to the hard stuff, but the next progression in difficulty for this binary would be to go, okay, let's pretend we can't use system, let's use exit. Let's actually try and figure out which libc, libc-2.24, yeah. Let's actually try and figure out which libc would be running on the target system. You know, what operating system do we think it is? What distribution of Linux do we think it is? What version of libc do we think it is? Blah, blah, blah. And try and get a copy. If we, for example, knew that the server was running Red Hat, and it was probably libc version whatever, then we can actually go and get Red Hat and go and get libc whatever, pull it out, and go, okay, so the remote system is going to tell us where inside libc exit is, where it's actually mapped in memory. We've actually got a copy of libc here. So what if we were to have a look at where exit is inside the libc we've got, have a look at where system is inside the libc that we've got, figure out the difference, and then use this leak here with some pointer arithmetic to then pivot it across to where system is. That would be the next step. Sucks for a couple of reasons. First of all, in Smashtastic's case, we don't have any libc pointers. We could probably find one on the stack, but it sucks because you've got to actually figure out what libc the remote system's running. And then for each libc on the remote system, you've got to go and get the copy of libc. You've got to, well, for each potential target, you've got to actually go and get a copy of libc. You've got to go and hard code into your exploit all these different offsets inside libc. It's just nasty. We'd rather a one-size-fits-all exploit. Doesn't matter what version of libc is running on the target. Doesn't even really matter which compiler was used to build Smashtastic, which we have to take into account. We want an exploit that just works in all scenarios. So that's out. We're not gonna bother doing pointer arithmetic. So we start to move towards using things like the leak of main, the main function inside the actual binary itself, and using dinelf, which, given a function which can leak data at an arbitrary address, any symbol in any loaded library can be resolved. Sounds perfect. We tried to use it last time, but we had some issues, but I think I know how to overcome those. To demonstrate it, let's use dinelf against this funnily named dinelf, where is it? Dinelf binary, which I created as my little punching bag. Let's write an exploit that actually uses dinelf. And so we're not allowed to use system. Let's even go so far as to say we're not allowed to use the exit pointer. Not allowed to use that anymore either. So it leaves us with things like, this pointer to main. So the first thing we need to do is write a function which implements the info leak. So we'll go def leak. We're going to leak data at a target address. What are we going to do? We're going to chuck out a pwn.log.info. Doing info leak at that. I figured out some syntax the other day for doing hex numbers in strings. What was it? 0 hash 10x 0 hash, no, hash 010x. Yep, perfect, that's what we want. Doing info leak at 0 colon hash 00x. We're going to, the last thing we're going to do is eat the prompt before we return. We're going to t.sendLine number 2 for an arbitrary leak. We're going to eat another prompt. When we do number 2, we get this other prompt here that we want to get rid of. T.sendLine integer, no string target. We want to get this here integer, cast it to a string and send it down the wire as a string. So for example, if we were leaking let's leak some pointers, we've got number 2. Let's say we wanted to leak this global variable. We would send it as a string. We'd send number 2, we'd eat the prompt, we'd send target as a string, we'd send the line, so we'd hit enter, and we'd get back the length, the value, and then we're going to do eat prompt to eat the menu. So leak length equals, we're going to cast it to an integer. T.recv, we're going to pull 8 bytes off the wire. It's going to come back as base 16. As we can see here, it's a hexadecimal number. So that's the leak length. And then the leak is going to be T.recv, the leak length. So we're going to pull this length off the wire. And then we're going to pull length number of characters off the wire. And that will be the leak. We're going to eat the prompt and we're going to return the leak. So, and then we'll do home.log.success got. We'll actually report what we got and then return it. So we're going to eat the prompt, we're going to leak the pointers, we're going to blast away some of the pointers that we're banning ourselves from using. Let's get rid of all this stack buffer overflow stuff for now. We'll comment that out. Actually, you know what? Let's leave all that there. Comment it out for reference later on if we need it. Then let's do, for example, print leak pointers stack var, just to test this leak function, see if it works properly. Let's run the exploit. Buff's not defined. Why did buff end up there? Oh, because I copied that from before. Oops. We don't need the length anymore. We just want that to be format target. Yep, let's try again. Copy paste coding for the win. Yep, cool. Okay, so we're doing an info leak at this address here. It got back stack var contents, which is this here, reporting on what it leaked. And then because we then printed it out again, it gets printed out again. Cool, so we've actually built a function which can perform arbitrary memory leaks. Let's use this. Actually, you know what? I'm gonna not comment these out. I've got discipline to not use them, because I want to use them in a sec to sanity check something. We don't want to do that leak anymore. Let's now use dinelf to, based on the leak of the main address, to go and hunt down the address of the system. So copy paste coding is going to be this here. So d equals pwn.dinelf. We've called our function leak, so that's fine. The address of main, in our case, is actually pointers main. So we're going to create a dinelf. Then we're going to do a d.lookup, and this is actually exactly what we're going to do. Look for system inside libc. So pointer to system equals that. And then if pointer to system is equal to pointers system, print, hooray, we found system. It is at 0. How do we do this again? Hash 010x. Else print system is apparently at 0, but dinelf thinks it is at it's going to be pointers system, pointers, and pointer system, PTR system. Cool, okay, so let's let dinelf go and look up system inside libc, and we've still got one hurdle to go after this works, by the way. And then if it got it correct according to the info leak that the binary does, we'll say, hooray, we found it. It's at blah. Else we're going to say, that's weird. You know, the leak said it's at blah, but dinelf thinks it's at blah. And we can compare the two, see what went wrong. And so dinelf is going to do a lot of magic. Based on this function here that we give it, which can perform arbitrary memory leaks, or info leaks I should say, it will then, starting off at the address at which we've had leaked to us that main is at, it will start there, it'll walk backwards, it'll walk forwards, it'll walk all throughout the memory space of dinelf, the binary, the process dinelf, until it finds a pointer into libc, and then it'll hop over to libc and start leaking up and down the libc range until it finds system, and will return it to us, and we'll assign it to pointer system, and then do this little celebration dance if it worked. So let's see if dinelf is on point tonight. We are not. We have a syntax error. There we go. Oops. Something got really unhappy. What happened? So we can see that dinelf was doing a whole bunch of info leaks. I think I did wrong. The leak function, we should actually go and tack on an extra null byte, because we know that the printf that is actually performing this leak on our behalf over here will stop on a null byte. So what we can do is we can actually go and tack on a null byte there to let dinelf know, hey, whatever just got leaked, there's a null byte following it. That stung me in the lab. Dinelf really likes to see these null bytes at the end of what gets leaked. Let's try again. That looks better. Cool. So we got a hooray message. We found system. It is at blah. So what was going on there? We can see that DinElf, first of all, it complained that no ELF was provided. Leaking is faster if you got a copy of the ELF being leaked. We're going to pretend we don't have a copy of the ELF being leaked because in the Smashtastic case, we don't. So it's doing an info leak, blah, it got blah, 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 blah. You can see it's doing a whole bunch of info leaks, it's getting stuff back, it's making decisions, it's looking for different things in different areas, and we scroll through. We see at one stage it tried to actually download a libc from the libc database based on the leaked build ID, and it got a 404, which means that PwnTools has to keep on doing things the hard way. It can't just go and snipe the publicly available libc, it's got to actually keep on walking until it finds system. Kept on going, and then it says that it found system. It is at this address here, which means that it matched the pointer that was leaked to us. So if we copy this, if we break into GDB and examine one instruction at that address, it is system. So PwnTools was able to find system for us. So now what we can do is we can grab all this here. So we're going to do a ret to libc using a DinElf system address. Instead of this pointer's system, we can go pointer to system. As per what we got back, let's get rid of, actually let's just comment out this celebratory nonsense here. So based on the d.lookup from DinElf, we got a pointer system variable. So then based on that PTR system variable, we can then do the same thing as before, a ret to libc, but this time instead of using the leaked pointer, we're going to use the pointer that we had DinElf find for us. We save that, we run the exploit, we can see it does the info leak and looks for system again. We get a breakpoint hit because we have a breakpoint set on the system, which I'll just quickly go and disable. We don't need that anymore. We continue, dash gets executed, and there's our shell, based on a address of system that that was discovered by DinElf. So there's one last challenge, one last hurdle. The API, the leak that we had in Smashtastic couldn't take pointers with null bytes in them. We had to return the special Python value none instead of actually using that null byte, because we weren't allowed to use null bytes in the bug, and that was causing us issues. So now this is all a reproduction of what I labbed up this week. So I wanted to get to know DinElf better because it was magic, and I still don't understand the magic as well as I wish I did. But at least I figured out a trick to get past this next trap. So when we do this leak target, let's go if nullbyte in pwn.p32 target pwn.log. I think it's log.warning Python. Okay, so pwn.warning. What we should use, pwn.log.warning was asked to leak target containing a null byte, returning none, return none. So if there's a null byte in the address that we were asked to leak, let's just return none from leak target and let DinElf go and figure out what to do. DinElf is then going to ask to leak the, do I still have that diagram? No, got rid of it. DinElf will go and take one step back in memory, byte-wise, and we'll leak from there, and then we'll chop off the first byte of what it gets back and go, this is what I wanted all along, which should cause issues. So we're just going to pretend that the this arbitrary leak API doesn't accept null bytes, and we're going to return none. Firing that off, then we get a crash, because it was doing an info leak at this address here, and it was asked to leak a target containing null byte, returning none, and so PwnTools is like, cool, I'll just take one step backwards, 1 byte earlier, and when you try to read from this address here, examine that there, not allowed to. If you just add 1 and go up to B0000, that's totally fine, there's stuff there, but there's nothing at this address. If we look at the crash, we can see that there was a dereference of EAX. EAX is just off screen. EAX is, around about that pointer, which was an illegal memory read. This is where we got to with Smashtastic. We had, sorry, let me know if hopefully the camera wasn't in the way there. Smashtastic the exploit was crashing because Dinelf was walking backwards off a page. Let me pull up the link I found this week when researching the issue. So this is a write-up of a CTF binary. Who's it by? Jim, GYM, gmiru.com. Thank you, Jim, gmiru. This was a lifesaver. So if you read through this write-up, I haven't read through the whole write-up because Google told me that it had the secret stuff I needed, so I skipped through to the end, where it says, blah, blah, blah. This can be further simplified with PwnTools Dinelf lookup. The problem is that the printf input is read by fgets, which terminates on null byte, so we can't directly read addresses containing the null byte. Exactly our problem. This is not a huge problem because we can still read from the previous or next address and identify the ELF header. I saw that and thought, okay, interesting, because it's probably walking backwards trying to look for the ELF header. So what they did was, if the lowest significant byte of the address was 00, then they would leak from the address +1. So instead of taking 1 step back, they took 1 step forwards. And if that 1 step forwards returned a string that started with ELF, then they would just cross their fingers and go, this is probably an ELF header. If 1 byte forwards has ELF, then we're going to return hex 7f ELF. Or hex 7f and then whatever came back from this leak here. So instead of going 1 back, they go 1 forwards. If they go 1 forwards and they see that it's ELF, then they just go, fingers crossed, we're just going to stick a 7f in front of it and hope for the best. If it doesn't start with ELF, they're going to return leaker -1 and keep walking backwards. The reason why they picked 7f is because the ELF header is hex 7f followed by ELF. So instead of taking 1 step back, they took 1 step forwards. If they saw ELF, then they would return 7f ELF. So let's give that a go. So if there's a null byte in the pointer, then what we're going to do is how are we going to do this? Thinking of the nicest way to do it. Let's just do it normal way. If pwn.p32 target dot starts with hex 00, actually there's an easier way. If target and hex ff, so we'll just mask everything about the bottom byte out, equals 0, then if leak target +1 dot starts with ELF, cross our fingers, return hex 7f plus, I'm going to do leak plus 1 equals that there. If leak plus 1 dot starts with elf, cross our fingers, return hex 7f plus leak plus 1. So this here should catch that case in which we're asked to leak something with a lowest byte of 0, then it would walk backwards off the end because it's the base address, because it's about to read elf. If the lowest byte of target is 0, we're just going to have a stab. We're going to leak target plus 1. If the leak of target plus 1, which we call leak plus 1, starts with elf, then we just cross our fingers, return hex 7f followed by what we leaked. Otherwise, if this if here fails, then it will just kind of continue through to the fact that if there is a null byte in the bottom byte or anywhere else in the target, just return none and let DinElf figure it out. This should at least catch the case in which DinElf is about to walk backwards off the pier and fall into an unmapped page. So running that exploit, we get a crash in Python. What's it complaining about? I know what I'm doing wrong. In a function called leak, I have a local variable called leak, and that's causing a collision with trying to use leak as a function name. I should not have named a local variable the same as the name of the function. That was my bad. That was very poor form. Let's make this the local variable of the Python function be leaked data. Got leaked data, return leaked data. Run the exploit. Different crash. None type has no attribute starts with. Right, because there's every chance that this here could return none if there's still other null bytes in the address, and you can't do, there's no function dot starts with belonging to none. So we can do if leak plus 1, and so if leak plus 1 is not none, so if leak plus 1 is something, then do this. If leak plus 1 is none, then this if should early out, and that shouldn't happen. Hopefully that's a documented way that Python works. Otherwise, this is a terrible hack, but that sounds pretty sane to me. If Python isn't guaranteed to early out, someone should let me know before I make a bigger mess of things. Let's run that exploit. There we go. Bin dash got executed, and we have a shell. Whereas, if we didn't have this little protection doohickey in here, if we comment that out and we just let DinElf walk backwards off the page, then we get this awful crash where it tries to leak stuff that it shouldn't be leaking. With this little protection snippet, which I basically borrowed from Jim's personal blog, it's basically my implementation of this logic here, then DinElf is prevented from shooting itself in the foot. And we get a reliable ret2libc based exploit. So yeah, now that I know this trick here, I should be able to use I should be able to just basically drop these couple of lines here in the exploit from the other night if I just wind it back a few steps before I started getting frantic and desperate. And the Smashtastic exploit should, fingers crossed, just work. Knowing our luck, it won't, and we'll have some other issue to troubleshoot tonight. I kind of rushed through that. I was intentionally kind of not keeping an eye on chat because I wanted to get through that so we can then move on to Smashtastic. But does that make sense to people as to how info leaks can be used in general? How retlibc works, and how an info leak can be used by DinElf to resolve a symbol inside libc. Does that make sense, or are there any questions, queries, concerns? Infinite entropy. Are you masking the function definition somewhere? It was that back when I was using the name leak for a function and a variable, because that's a good suggestion. Python short circuits in Boolean evaluation. Awesome. Is it guaranteed to, or is that at their discretion as to whether they are early out or not? Because I love stuff that early outs, but at the same time I hate to rely on it if it's not guaranteed. Infinite entropy. I don't think I've seen you around before. Good to have you around. Hope you're enjoying this. Good to have you here. Yeah, cool. I'm going to fill my water bottle up. Anyone have any queries, concerns, or should I let that kind of marinate and I'll go have a quick break? If people need to have a quick 5-minute break, now's the chance. That's what I'll do. I'll go have a quick break and I'll come back, and if there's any questions, if there's any comments, any queries about how retlibc works, how info leaks work, or how DinElf works, we can chat about it then. So if anyone needs a break, now's the time to do it. I'll see you all on the other side of this.
Jack it up. Suck the life right out of my veins when you spoke my name. Got the kind of thing going that tips the scales. Yeah, you keep me sane. I'll be the clouds beyond your skies. I'll flutter by like butterflies. I'll be the blue inside your eyes. Your crazy loving keeps me paralyzed. Oh, this is what it feels like. Oh, this is what it feels like. Oh, this is what it feels like to see reflections of you all around. Oh, this is what it sounds like. Oh, this is what it sounds like. Oh, this is what it sounds like to hear reflections of you all around. Wanna taste you again like a secret or a sin. Wanna feel you again like the ocean sand on my skin. I'll be the fight against your fears, forever here to save those tears. I'll be the courage in your wings, not letting go, I'm all you need. Oh, this is what it feels like. Oh, this is what it feels like.
Hey everyone, I'm back with my water, ready for some more. Were there any questions or did anyone want to chat about return to libc, that dinelf binary, the dinelf Python function, anything we've covered so far? Was any of it unclear or worthy of discussion, or should we just power on, see if we can knock Smashtastic over and call it a night? What do we want to do? I'm going to take the silence as we're happy to keep on going. Let's see if we can use this same logic to fix up our Smashtastic exploit. What have we got? Smashtastic.c, Smashtastic exploit. Oh, I've already got it open somewhere. Ah, here it is. What have we got open? Okay, cool. So what did we leave this off as? Smashtastic, actually. Let's turn NX back on because we think the remote target does have NX. That's right. Don't have a 32-bit compiler in the Docker container. Work, Smashtastic. There we go. Yes, okay, we don't think the target has ASLR either. Smashtastic exploit, local. What did we leave this off as? It's probably got a lot of horribleness in it because I was desperate. Let's get rid of this here. And uncomment this. I think this is what we had breaking on us last time. Don't need those leaks. D equals dinelf leak. I don't need this math. That was a desperate attempt to trick dinelf into working. We don't need that anymore. Leak pointer into getnum. What was that doing? That looks fine. Don't need that. Don't need that. Okay, so locally, yeah, same issue here. We've got dinelf walking backwards off this page and causing a crash. So let's look at our leak function. What have we done? I think we didn't end up needing offset. Yeah, so we'll get rid of that, get rid of this. So what are we doing? If there's a null byte in it, let's change this info to a warn. Return none. We have a tag, we've got some padding. Trigger the format string bug. So the tag is when we stop reading. Get rid of that. Okay, that looks a bit saner. So now what we're going to do is if target and the lowest byte of target equals 0, then if leak target plus 1. What was the logic again? I'm trying to redo it without actually looking back at what we just did. If the lowest byte of target is 0, then if we wanted to we've got to rename this here, leaked data, leaked data. Data leak plus 1 equals leak target plus 1. If leak plus 1 starts with elf, then cross our fingers, return hex 7f plus leak plus 1. Otherwise we fall through to, if there's a null byte in it, we return none. And then do the leak. Let's see if basically adding these couple of lines fixes this exploit locally. Well, then again, no, it's not an exploit yet. All we're doing is dinelfing for system, doing a lookup for system and printing it out as hex. So it's not an exploit just yet. target and that. Equals equals. That could have been really bad if Python wasn't good to us like that. Crash! Did it find it and then crash? Is this system right here? No, it's not it. I don't think. This output went totally screwy for some reason. Is this new line causing problems? Probably. Yeah, probably. Interesting, because in the DINELF one we didn't care, we didn't account for new lines, but that's probably a bug in the DINELF exploit. We probably can't use new lines. I mean, what is this? Yeah, we can't use new lines here. Let's add another check at the beginning here. If new line in pwn.p32 target this is getting kind of ugly. It's due for refactoring, but not tonight. Ask delete target with new line. Returning none. Let's see how that goes. Something weird happened. Could not find tag DT debug. I mean, is that just RNG killing us? Are there some layouts of a certain ASLR that don't work? Let's just try that once more. No, something's wrong. What's happening? What about remote? Does it work against remote, just like magically? Let's just add to these warnings. I think I've got threading or something maybe causing interleaving of log messages, or maybe it's like a buffering issue. Let's just go and quickly just whack some verbosity in these warnings. One thing I want to do that I saw that I don't need to encode this data here because pwn log info will hopefully pretty printed for us anyway. Let's go local again. Yeah, it's getting stuck on this address here locally. Remotely, what's it doing? Looks like it's getting stuck on the same, or it's getting stuck on something else. And it's getting further than it was the other night. At least now it's getting into libc. Yeah, it's getting stuck here. So, I mean, locally, what's it hitting up? Where in libc is it getting stuck? Or a pending null there. Yeah. Maybe Dinel's not going to help us anyway. Let's go to a simpler test like we were doing the other night. Let's, instead of that there, let's go print d dot bases. Okay, so I can find locally a bunch of library bases. Remotely can I find library bases? Nope. Yeah, it wasn't going to be so easy as to just drop those lines in and have it work, was it? Okay, what else does Dinolf give us that we can test with? What if we just ask for libc? Got stuck on something remotely, and locally it got stuck. It's not happy with us returning none for this here. Mind you, Dinelf's not falling back to its normal -1 behavior for this particular pointer. Elsewhere it was it? Yeah, so like here, for example, when it was trying to leak something that ended in a null, it was taking a step back. But maybe once it gets to libc, maybe this is a Dinelf deficiency, or maybe it's intentional on behalf of Dinelf. Once it gets to libc, oh no, here it is in. This is the binary. This here is libc. For that there, it took a step back. For this here, it took a few steps back. For this here, it took a few steps back. Oops, I was looking at something else there, I think. Is that the remote one? Yeah, it was. My bad. So here's the local one. Actually, you know what? Let's get rid of that. Let's do that. Okay, that worked. So must have been this. I might look into this another night, but let's see if we implement the take a step back behavior ourselves. Take it out of Dinelf's hands. Will it overcome a Dinelf either deficiency or design decision? I'll look into why it's not taking a step back another time, but I'm getting desperate and want to go to bed. So let's do I'm going to fold this down into the next little area. That should make a difference to reorder it. If null byte in that, or new line in home.p32 target, oops, cheating. Let's go ahead and return leak target -1 from 1 onwards. That's what we want. Python ABCD from 1 onwards is, yeah, BCD. So we're going to leak from target -1 from 1 onwards. But that's really only going to work if the null byte's in the, or the new line's in the lowest byte, otherwise it's going to have to move quite a while back. In which case, bugger it, return none and cross our fingers. I'm just going to yank 2 down. That in there, or this is looking horrible in phone.p32 target. Now, so that's that one there. If target and OXFF equals OX00, or target and OXFF equals OX0A, null, or new line in LSB, cheating. So if we do the ELF cheat, if the lowest, if the LSB is 0, or just for good measure, target and OXFF equals 0A. Really, this here should be wrapped up, should be brought up to this if here. So let's put that there. Yeah, so we do the ELF cheat. If the ELF cheat fails, we do the take a step back cheat manually, because we don't trust DynElf to do it now for us. And if it's not in the LSB, then if it's anywhere else, then we return none so that DynElf can figure it out itself, otherwise we do the leak. Let's try that locally. Nope. It's unhappy. Let's go and that's a shame. Let's try that remotely. Okay, now I don't trust PwnLog to encode stuff for me. I'm going to encode this myself. Let's do it locally and sanity check some of these leaks. Maybe our leak function's broken. Is there a null byte at this address? Yes. Is there a null byte at this address? Yes. What's here? Okay, so because this OXOB is getting hidden from DNF because it's going one back getting a null byte, going one forward getting a null byte, EFF, E00 becomes DFF. Yeah, there's a null byte before it, so this 0B is getting hidden. Which might be tricking DNF into getting stuck. Does the bases work against the remote target? No. Same thing, I reckon there's a byte getting hidden from DNF, and so DNF's getting stuck. Maybe DNF's not going to help us anyway. Maybe DNF struggles when there's this string style leak going on. In certain circumstances. Can we just get a libc address and then do stuff ourselves? A libc base address. Locally. Nope. Do it remotely. The bases works against us but not remotely. That sucks. Yeah, we can get the libc base address locally. But not remotely. Can we get libc locally? No, that breaks. I can think of a horrible way to leak stuff with nulls in the bottom in the LSB, but I don't really want to do it. I think we can basically plant that address on the stack in one pass with a non-null in the bottom address and not trigger the format string bug with the %s. So just not do that, you know, pad that with padding characters. No, because the address comes first. If we could move that address to after this here. Hang on. We've got padding. Then the target pointer. That's just a tag. Yeah, we could do one pass where we make the LSB not be null. We could make it be 0, 1. And then trigger this code path again. And do a partial override of what we just left on the stack, which would end up dropping the null in the right spot. No, because then the printf wouldn't do its job. No, we can't use residual stack contents to plant a null there. Not going to work. Oh, Jodeth, good to have you around. I'll catch you next time, eh? I'd say it's additional security implementation by chance. I mean, with this sort of challenge, there's a lot of different ways that people can kind of go about it, so I'm not sure whether our approach was actually being kept in mind by the author. But it's just a deficiency and a limitation of DynElf that we're hitting by chance, I reckon. Because DynElf doesn't do well when it can't use null bytes, and then it ends up having bytes hidden from it, and it can't continue. So I think it's just, yeah, unlucky. What are we going to do about this? This is an evil challenge. Thanks, Blue Pill. I think DynElf's dead. I think DynElf's dead to us for this one. I don't think we can recover. So what are we going to do? Let me just see if we can convince the remote server to give us any pointer into libc. Let's see if DynElf can basically just cough up directly a pointer into libc if we give it something to resolve inside libc that should already exist in the GOT. Yeah, let's do that. So what will already exist and be populated in the GOT? Printf. What if we just ask for printf? We're not asking for much, we just want printf. No, locally it doesn't want to do it. No, remotely it doesn't want to either. What about if we just ask for link map? I don't know much about how the link map works, but if this works, we're going to find out. See if we can make use of it. Link underscore map. Okay. That's not inside the binary. What is the link map? What's the link? The link map. This looks gross. This looks really gross. We're not in Kansas anymore, are we? We're really deep in this one. I don't even know what I'm looking at here. Okay, yep. Yeah, okay, right. This is actually interesting. We can probably this head off. We can yeah, map. So libc is at on our machine F757 F000. Okay, we can even though Dinelf's not helping us, we can probably walk this somewhat trivially ourselves and find the base address for libc. Then we might be able to see if we can steal the build ID, go and get a copy ourselves, have a look at it, and then do that awful offset calculation stuff. I know I said earlier we wanted to have a generic exploit, but Dinelf seems like it's being vastly unhelpful. So if we can walk this link map ourselves, we might be able to find the base of libc. This is not fun. This is not fun. So let's go tally that. Yeah, if there's null bytes in any of these pointers that we want to walk, then we're in trouble. Okay, let's give this a go. Let's define leak libc base. We're gonna get the head of the, I think it's gonna be, what's this gonna be, like the head? Is that what you'd call the first thing you can see in a linked list to a certain location? Let's call it the head. Link map head equals let's just call the link map. Link map equals d.linkmap. Just go and fetch it out of this d that has to exist by the time you call this, otherwise things will break catastrophically. So it's going to give us, for example, this, which looks like this in memory. So then we want to leak the 32-bit pointer at the link map plus 12, which will be the first thing, which will then, once, if we were to dereference it, looks like this. You can see that at offset 4, there's a pointer to a string, which is the name of the library. We just keep walking until we see libc, I guess. And if that one's not it, then we go to 12 and then follow that, and we get something with libc in it. So back to that first tally. So what we're going to do is we're going to, starting from the link map, should we just kick off an infinite loop and then break when we need to? Return to do. While true. While true, we link map next equals link map next equals link map. While true, okay, let's just keep on walking this link map along. While true, link map equals tone dot unpack 32 at leak link map plus 12. So we're going to, starting at link map from d.linkmap, we're going to add 12 bytes, which points us to here. We're going to leak that. Just get the first 4 bytes. Is that how you do it in Python? A, B, C, D, E. Yeah. So we're going to slice the first 4 bytes off. We're going to unpack it as a pointer. I'm going to leak that plus 12, get that. So that's going to turn it from that into that. Let's go tally that. We then need to leak this pointer to the name of the library. Pointer lib name equals pwn.unpack32. We're going to leak link map plus 4. Slice off the first 4 bytes. And then let's just print leak pointer lib name. Just for fun, let's kick off this infinite loop and watch it crash. But let's see what happens before it crashes. We should probably call the function we just wrote. Leak libc base. Yeah, cool. We just leaked some library names, hooray! Let's see if it works remotely. Why does it work locally but not remotely? Can we not even just get a DINOF instantiated remotely? Like, is that where it's failing? Not even when it's doing any sort of decent lookup, is it just failing that soon? No, that's fine. Print d dot link map. That works remotely. So what in here is not printing out anything useful remotely? Just pwn.log.info leaking libc base address. Let's not print this, let's pwn.log.success so we can see it stick out. Okay, so it's finding link map. This is annoying me now. is the link map just not populated remotely. If this is a statically compiled binary, I'm going to be super pissed. Super pissed. If there is no libc remotely, I'm going to be really cheesed off. I mean, we saw libc being walked before, so there should be a libc there. Should be. Let's just comment this and let's go do.libc remotely. You know what? Oh, there's too much noise here. Let's. I'm just going to turn off this logging so I can see what's going on. You know what? Before I do, I'm going to print this. Let's turn this logging back on. Like if Dinolf's getting stuck remotely on trying to walk link map, maybe it's a statically compiled binary remotely. Get rid of this comment, let's try again. You know what, I'm going to try something crazy. Let's assume it's statically compiled. I just want to try something really quick. Instead of these, let's print hex. You probably can't Dinolf stuff inside the binary itself. Let's just see what happens if we compile this statically linked locally. Does it fail in the same way? Yeah, do we get this same sort of failure locally for a static binary? Is it just dash static? Okay, so that's static. Now we'll do that local. Okay, no. So if we have a local static binary, link map dies sooner. So we can probably assume that remote is not static. We can probably assume it's a dynamic binary. Any ideas, chat? Is that a question as to what statically compiled means, Barney, or did you think it was statically compiled before I went down that track? Yeah, that's it. Hey, Mr. Fluffy Tail, if you're still around, yeah, we're doing some pretty out of my depth stuff actually. Trying to use an info leak to find system in a remote service. They do indeed. So the pokey people need to deal with the trolls in a couple hours. Oh, Infinite, you're Sydney. Very cool. Does Denelf assume glibc? Maybe it's... yeah, maybe. But even if it's not glibc, then me trying to walk this... what is it called? The link map? Me trying to walk the link map should give me something relatively sane, I would think. Can we run this locally? Then we're at least getting some library names successed out. If we do it remotely, then we get empty string, and then it dies. It fails to walk this link map. So the difference that I'm seeing right now is the difference in behavior of how the link maps work. I mean, maybe there's different offsets in different implementations of the link map, maybe, and maybe Denelf walks them more cleverly. Like maybe I should read through some of this and see if we can see how the link map's used. Where is link map referenced? Okay, looks like there's really only a 32 versus 64-bit link map, so there's hopefully not multiple implementations of link maps going on, at least as Dinelf sees it. Can we just use this function directly, maybe? Dynamic load Dinelf looks up information about a loaded library via the link map. Returns a Dinelf instance for the loaded library. Can we reach out to this from inside Python? Print hex d dot, what was it called? Dynamic load Dinelf. Ah, come on. There we go. Does that work locally? Okay, so that worked locally. Does that work remotely? No, so Dinelf gets stuck remotely, even doing this. But you're right, Infinite. You might be totally right. You know, stuff like I'm not totally up on alternate libcs, but does non-glibc libcs come with a name that doesn't contain libc? Maybe. Like, again, I'm not up on. Barney, did you silence or kick or something to Infinite? Yeah, not at all. Consolation blue pill. That just annoys me even more. Yeah, like Infinite alternate libcs should still have the name libc in their name. Yeah. Like, yeah, it's failing even to. Dinel's failing to call this on libc remotely. Where's it getting stuck? Oh, it's getting stuck on having a byte hidden from it, I reckon. Maybe it is getting through the link map, it's just failing when it's trying to be really aggressive about something else. I'd say that's what it's doing. So maybe we just suck at walking the link map. You know what? I'm going to duck off for a quick 2-minute break. I'll be back in 2 minutes. Please don't go anywhere. My numbers drop each time I leave, but I'll be back in just, I promise, 2 minutes. 1 second. Hey, we're back. Any ideas for where we go from here? Do we just have to go back to trying to make sense of that remote link map and see if... I think we do. I think we need to get better at walking the link map. So this works locally but not remotely. Let's comment this out. Just go and leak the libc base again. So locally, we walk off. We get all these successful names of libraries and then walk off the end and probably break stuff. Yet it doesn't work remotely. F772 EE. Then it goes up to EC34. Do we need to walk backwards instead of forwards, maybe? We're falling off. Maybe we're not getting back the head of the list, maybe we're getting back the tail of the list. In which case, let's go like plus 16 remotely, and let's see if this successfully walks something useful. Nope, crash. Or a Python error, I should say. Stupid thing. Where's that link map base? Here it is. So this is the link map on our system. Okay, so the L address is 0. The char star for L name is this, and so the string is empty string. Dynamic section of the shared object. This here is a pointer into the binary itself. And then L next and L previous. This is next and this is previous. If we go and look at the next link map, then we get this, which we're doing over here. We're basically dereferencing link map plus 12. To get the name, we're dereferencing plus 4, which is this here, which is a pointer to that. Whereas on the remote system, that there is coming back empty string. trying to pivot to the next thing and then crashing. F777 B9. Like, what if we just, on the remote system, just walked and printed all these as strings and just kept on going? Let's just do that and see if we get back anything that looks like libc, or any sort of names of libraries. So while true, let's just print, no, let's pwn.log.success leak link map, and then link map plus equals 4. Let's just like walk memory until we fall off the edge. We do that locally, and what do we get? Helps if we call the function. No, we need to dereference all these. We can't just dump it. I'm guessing. Let's, if .so in data equals there's no successes in there anyway. And we've got to dereference stuff, not just dump out all of that. While true, data equals leak that. If len data greater than or equal to 4, then we'll dereference it. Delete that, delete that. Print leak pwn dot. No, I don't even need to do that. Let's just data first 4 bytes. It's complaining about something. What's it complaining about? Why is it complaining about that? Because we need to pass an integer. Pwn.unpack32. We cannot be guaranteed we're going to get back pointers, but I guess if we're getting back at least 4 bytes, we can assume it's a pointer and probably be pretty safe. Crash. Yeah, that was a super dumb idea. Back to where we were. That was a bad idea. I'll do that again. This is nasty. Have I fallen way too far down a rabbit hole? Is there an easier way to do this? Is there an easier way to do this? Well, I'm going down this trying to walk the link map so I can find the base of libc, so I can leak the build ID, so I can go and fetch it off the internet, so I can then have some information about the remote host. Is this going way too far down a stupid rabbit hole? Like if remote NX is on, and I'm pretty sure we decided last time that NX is probably on, probably. Would we didn't conclusively determine that NX is on. Maybe it's worth revisiting there. But if NX is on, ROP is out, because we don't have a copy of the remote binary. I mean, we know ASLR's off remotely, but we can't mine the binary for gadgets, and I don't really want to have to leak the whole binary remotely. Or is it worth leaking the binary remotely to see if NX is on? That might be worth doing. Use the info leak to kind of walk through the binary and try and find the security flags. I'm not sure how those flags are stored. But is there an easy way to find the base of the binary and explore it to see how it was compiled? Probably. Vape Nation. Is it bad? I mean, hey, doesn't? Yeah, no, that's totally normal. I'm glad you're feeling my pain with me. We're all on this ride together, and this ride sucks, and we're not going to get off, but it's not fun. Yeah, can we remotely interrogate this to see if we can decide if NX is on? Does PwnTools give us that? Does PwnTools, with any of the leak consuming functions, tell us more about the binary? What is the dynamic area? Dynamic. Does Dinolf give us a way of finding the base cheaply? I want to just go through the defs in here to see what sort of stuff powers this function. Okay. Looks like we could just do like a find base. Sure. To a library. Can we just use this to find the base of the binary? Print d dot find. Yeah, blue pill. So you should. Nah, it's been a good challenge, dude. I've really enjoyed this. I've learned a lot. It's painful, but learning. What do we do? Just pwn.dinolf.find base. Like, is that going to find us the base of? Yeah, neat. Oh, cool. The base of the remote binary is processed at the same location as ours. Which is this here. If we wrap that in hex, we should get. Yeah, neat. That's kind of cool. Like, is it worth just basically walking that entire thing and dumping out as much as we can to a file, get as much of a copy of the remote binary as we possibly can? There will be gaps in it. There will be gaps where the cheats fail. If the cheats fail, what's going to happen? We're going to get like empty string sometimes. But it might be sane enough to at least do like a check sec on it of some sorts. Maybe. It's going to be messy. Valid exercise, I guess. Can we just pointer to smash tastic base equals that. How are we going to walk this and actually catch the crash? Would you like a try? Try print 1 over 0, except print, we got this. Yeah, so as long as pwnlib raises an exception when we get end of file, and we try and do a read but we can't read because we've got end of file, then we can probably catch it with except try while true bin equals empty string, bin plus equals leak let's go pointer equals this, bin plus equals leak to pointer. Let's go data equals leak pointer, bin plus equals data, pointer plus equals the length of data, yeah, like sometimes we're going to get none back and it's going to totally break us. A plus none, blah. Then none. If data, append it to bin, pointer plus equals else, pointer plus equals 1. We're going to get such a broken binary back. Data plus equals, let's go and just put a null. If we get none back, let's just go fill it in with nulls. This is awful. And then just push pointer forward by 1. While true, do all that, except with open smash tastic leaked binary as f dot write data, no, bin. This is feral. Let's just do this locally and see what we get. Hey, we just gone and leaked something that looks like an ELF file from ourselves. That's kind of cool. So we leaked this off ourselves. Yeah, we got some string data. Looks like, I don't know, it's not great. File buffs on it, but it's probably a null byte there that it wasn't happy with. But let's leak the remote one and just see what we get. It's better than nothing. Maybe it's not better than nothing. Maybe it's going to actually send us astray, but we'll see what we get. Actually, do we have what's A from 1 onwards? Empty string. Okay, it's Oh no, that's fine. That's totally fine. The thing is, with whatever mess we get back, will we be able to check sec it anyway? Probably not. Probably won't be able to be parsed by anything that can do check sec for us. I'm getting a whole bunch of null. It's probably going to have to get to the end of this page now, which is almost there. There we go. We've got a leaked binary. Cool. Is this going to give us anything useful? So we can see a reference here to libc.so.6. Is that glibc when it's named like that? Interesting. I mean, it looks like it's dynamically linked, at least. Ah! We get compiler information. That's super handy. I definitely removed the file before I did all this, didn't I? Like, I'm not accidentally looking at my own leaked binary, am I? Yeah, I removed the leaked binary before I did this. I'm not looking at my own. It kind of scared me to see that theirs is Debian and I run Debian. It's like, ooh, am I looking at my own? But okay, so we get some. So we can see it's compiled in GCC on Debian. Yeah, thanks Blue Pill. Oh, are we seeing it twice? Yeah. Okay, well, I mean, can we run this in GDB to do a check sec? File format not recognized. Let's go and get the external check sec, see if it can make sense of it. Is there a newer check sec somewhere, or is this really all we get these days? I don't really want to run arbitrary script I just downloaded over HTTP. What can we learn from just hex editing it? I mean, can we look up where the NX flag is and hope that we haven't just nulled it out because we felt like nulling it out? Elf NX flag? I don't know. So execstack can query the executable stack flag of ELF binaries. How does execstack work? Oh, this is promising, glibc. Okay, so how can we make sense of this PT GNU stack program header entry? Do I have execstack installed? Let's see if execstack can make sense of this broken binary. I'm not too hopeful. Let's do it on ours first. Smashtastic. Gave us some minus, which I'm guessing means it's not executable, and that's done on a leaked binary. Not a shared library. Yeah, it's a broken ELF file. I don't really want to dive into the source code of execstack and does LDD make sense of leaked binary? Nope. Is it worth just fishing a pointer into libc off the stack and then trying to do a find base on it? Then walk forward to get the build ID, pinch a copy, discover offsets. Could be. And again, I'm kind of curious to see if NX is on this stupid remote binary. This doesn't really tell us much, does it? Pretty sure this here's the build ID. These may be the entries that may have NX in them. Let's look, what's PT GNU stack? Oh, 6474E551. 6474E551. So this here is the PT GNU stack segment type identifier. So now we just need to parse this here. Or something. ELF file format. Okay, so we're talking about segment types. Does this talk about segments? So the program header table describes 0 or more segments. So where's the program header table? Program header. It's found at file offset EPHOFF. It consists of EPHNum entries. Okay, so where's EPHOFF? It's at OX1C, offset OX1C. Full of nulls, or no, 20. Well, that's 1F, that's 1C. Is that a big endian pointer? Making this the PH off? It's a 4-byte field. Or have we just failed to read this pointer due to nulls? Maybe. FEDC. Oh, well, let's EPH num is at OX2C. Okay, anyway. Program header. Not adding in nulls properly, it's just ignoring them. Is it? Because if I do if data came back as not none, yeah, if data comes back as none, we do this. But if data wasn't none, I append it and then advance pointer by the length of what I got back. Else I whack a null in an advance pointer. Is that not there compensating for me adding in the right number of nulls? Binary leak code is not adding in nulls properly, it's ignoring them. Because if I got back a single null from leak, because leak leaks null terminated strings, and if I got back a null byte, it means it just hit a null byte straight away, because I do append a null back in leak. But if I got back none from leak, then I go and chuck a null in myself. Is that not covering it? But you overwrite data. Oh, that should be buff. Thank you. You're right. That was supposed to be buff plus equals null. Not data, because data is what I leave. It's my fault for picking stupid names like data and buff. That is totally my fault. Thank you for that. That's a great catch. Let's call it leaked data. If leaked data call this bin. Oh, hang on, was I calling it? Yeah, buff there. Okay, so it's actually should be bin, not buff. God, okay, so bin is nothing. Pointer equals the base. Try while true. Leaked data. We leak some data. If it didn't come back null, we append the leaked data to the bin. An advance pointer by the length of leaked data. Else, we just chuck a null onto bin. An advance pointer by 1. Thank you very much for that. That's good catch. Should we even not buff? Yes, it should. It's 11 o'clock. I'm just going to blame the time for that one. F.write bin. Oops. Let's remove leaked binary. Let's try this again. That might make some of those offsets make more sense. Maybe it'll even make the file make more sense, just to the point where GDB can pick it up. Maybe. Maybe. Okay, so yeah, well, this value, these types here kind of go in as part of this table of segment types. Oh, and then the princess is in another castle. It's actually a pointer to where it is. Okay. Come on. Yeah, now it's just getting the trailing nulls, I reckon. Oh, I've got a relatively early morning tomorrow morning. I've got errands to run before work. That's not going to be fun. Alright, there we go. File, leaked binary. That looks a lot more sensible now. Thank you very much, Infinite. XXD, leaked binary, pump it to less. This is making more sense to file. So maybe GDB can pick it up and give us a check sec. Nope. File format not recognized. Can exec stack make sense of it? Bogus SH link value. Oh, well, I mean, at least the tools are recognizing it a bit better. Let's go back to that hex dump. Let's see if this makes more sense now. So at offset, OX1C is a pointer is EPH off. Start of the program header table. So OX1C is 34, which is kind of the sensible default value. Okay, this is making a lot more sense now. Thank you so much, Infinite. That's a great catch. And my severe bad. The number of entries in the program header table is at offset OX2C. There's 8 of them. Because it's a 2-byte field, that one. So at 34 is the program header, which is here. Looking for a p-type of E550. There it is, E550. So that there is the PT, nope, not looking for EH frame, looking for E551. There it is. This here is our PT GNU stack PT value, type value, p-type value. Okay. Offset of the segment in the file image is coming up as null, because why not? Go to the rest of the segment in memory. It's coming up as null. Hang on, so we've got how many fields? 1, 2, 3, 4, 5, 6, 7, 8 4-byte fields. 1, 2, 3, 4, 5, 6, 7, 8. So the second last one is 7, the very last one is 10. So the segment dependent flags are 7, which might be something to do with our NX bit being on or off, maybe. And then the P align, 0 and 1 specify no alignment, otherwise should be a positive integral power of 2 with blah 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 equating blah mod blah. I think we can probably ignore that. P flags, is this going to tell us, is this 7 value going to tell us something about the state of NX? P flags member specifies permissions on the segment containing the stack and is used to indicate whether the stack should be executable. 7 to me means read write X. So the stack's executable. Okay. Does that make sense? Does that sound sane? The P flags member specifies the permissions on the segment containing the stack and is used to indicate whether the stack should be executable. The absence of this header indicates the stack will be executable. So the absence of the header means it's executable, but if it's there with a value of 7, does that sound like RWX to everyone else? We don't know. Like mine was. I did it with NX on, but let me bring up the briefing for this one. gpickview work smashtastic is it called? Yeah, smashtastic.png. To solve this challenge, you need to pop shell on the server. Once there, you should be able to find the flag at blah. And this to me, the shellcode from the Nopstar challenge to me kind of said, oh, it's probably got an executable stack, but I tried an executable stack last time and got nowhere with it. And then the comment is it's a 64-bit binary, which was a lie, and no stack protector. And we can tell this is definitely a lie now with file leaked binary being 32-bit. So we probably should have actually stuck to the plan of trying NX. Probably. All right, let's go back to old school. Dep being off. We've got that bright integer anywhere primitive. Like, what if we just spray the stack with a pointer to something that we know is containing something we control with bin shell shellcode? Let's comment this out. This exploit's starting to look horrible. Don't need dinoff anymore. Get rid of dinoff. This here was our old exploit for straight up execute shellcode on stack. It's probably in a bit of a state of disarray though. What have we got? Someone's getting blown up. Missing the most important, obvious, but important element. Yeah, Zoltralord, are you the author of this challenge by any chance? I'm pretty keen to keep on chugging along, and even if I end up solving it a roundabout way, if you know the way to do it, I'd love to hear about it probably after I finish it. I'm pretty keen to do it blind, pretty keen to do it fresh. But yeah, Zoltralord, what's do you know what's going on with this binary? Do you? Have you solved it, or did you write it, or do you host it, or are you involved with the CTF from which Blue Pill pinched it? Curious as to okay, just trolling. Gotcha. Alrighty, so where were we? So last time I was doing this trick where I kind of go one deep in the recursion, leak a stack pointer, throw away until woot, get the leaked stack pointer, wrap up the recursion, send AA, put shellcode where that pointer pointed to, And spike mains SRP with this pointer. And send -99. I think this worked locally. Crash locally, hey? Oh, I've probably got NX back on. Yeah, I do. Let's turn NX off locally. Let's try that local exploit again. Another crash. Did I mess with that offset last time? Is that what I did? Spike main SRP. Yeah, I think I messed with this a bit last time, which I now regret. Yeah, I really regret that now. How did I figure that out? How did I get that offset? What if I just spray it? I'm too far beyond caring to do this properly. I should probably go back sometime and do it properly again, but I just want to get this done now. For I in range 0, 128, in range 128 on 4, and that plus I. Where am I getting a crash? Why am I getting a crash on Pop EVP? T.sendline hex CC. Sigseg V. I've probably smashed an important local variable. That's what I've done. Why am I divided by 4? Not a format string anymore. I'm fading quickly. Spike. Where's this print coming from? Don't need that anymore. This here should be full of the pointer, not full of nulls. That's a bit odd. Where's that seg fault coming from? I want to messed up that offset maybe. It's there isn't an indexing by 4. This is an array write, an array based write, so it has already got a multiple of 4 in there. Ah. It's not just for you, it's also for me. I'm determined to get this done. It's killing me. You know what, I'm going to take a quick 2-minute breather. I'll be back in 2 minutes, and I'm pretty determined to get this done or pass out trying. So back in 2, I'll see you on the other side. Oops, just gave myself a small heart attack when I brought the stream back on and realized I should triple check that the email I just had open was really closed. An open source project has pushed some, well, not pushed, but has given me some private patches for some security bugs, which I'm really excited about, because if they look good, then they might get pushed to the public this week and I can go ahead with some disclosures. I've got some not fantastic bugs in the pipeline for disclosure, hopefully this week, but I reckon they're pretty cool. So fingers crossed I can disclose them sometime shortly, and then do a stream about how they were found and what they mean and how to exploit them. So that should be good fun. That will be coming up once the project finalizes these patches and pushes them out. Now, why is this spike main SRP causing a seg fault? Go that +1, run it, seg fault. Why is that ending up there? It's not at all what I wanted. Thanks, Parks. Hopefully we can chat about them soon. Is my shellcode actually here? Nope. Do I have a lack of eating prompts going on or something somewhere? Do I need to wrap up recursion again, maybe? I don't think I need that anymore. Where's that coming from? Why am I getting a seg fault? This is like working locally the other night until I started butchering it. What have I done to it? Let's just try this. Okay, so that's fine. Okay, so it gives us a crash there. So there's not a problem with the spike main SRP function. It's a problem with something I'm doing before it. Am I forgetting to eat a prompt or something somewhere? Alright, that worked. So what's going on in here? Swap those back out. Okay, that got me a shell. Right, okay, so that's working locally now. Just wasn't happy that I was sending a breakpoint up there. Alright, let's see if this works remotely now that I'm doing a spray of that pointer. And now that we're certain that NX is off on the server, so I was more confident in actually building this spray. Let's see if it works remotely. I'm going to be so pissed if this works. End of file. Yeah, dead. Okay. Let's go and do... that. Let's print hex of pointer to plantable string. Index AA. That's actually not going to work. Okay, so why is this working locally but not remotely? End of file. I've had like a bug fly in my water bottle. Great. Just what you want. Nah, it's still good. Like, are we reading that NX thing wrong, or is there something wrong with our spray of the pointer? Something wrong with the pointer itself? Are we failing to plant shellcode here? Are we stuck in a jail that doesn't have bin shell? Or a jail of some sort, a cheroot that doesn't have bin shell? Like, is that what the program said when it said your source code for ROPstar or NOPstar might be useful? Are you still around, Blue Pill? Do you get the same error locally if you set the NX bit? Well, it's not really an error. It's getting an end of file back, which means that the remote process crashed and hung up the connection. So I probably would, but I'd also see in the debugger that there was a crash. And that would be because, yeah, it's crashing and sending EOF. Blue Pill, do you have access to the challenge briefings? Smashtastic. The shellcode from the NOPstar challenge will be useful here. Do you have the briefing for the NOPstar challenge? Because the NOPstar challenge might be telling us something about the fact that there's a chroot and bin shell's not available, or it does say you'll need to pop a shell. But I'm wondering if the NOPstar challenge gives us any more detail on why that shell code will be useful. Because maybe there's some protection or something that we need to overcome. If you could, yeah, if you had access to that, that'd be sweet. If not, we'll have to just do it blindly. Okay, cheers. Have you done the NOPstar challenge? Okay, doesn't say there's anything special about it. Cool, thank you. Like, what if we just print leak that code hex. See if our shellcode looks okay. There a .decode hex? It looks like shellcode to me. So the shellcode is in the right spot on the remote host. Let's get rid of that null byte at the end there. And the shellcode's not corrupted. No worries, Blue Pill. I think we're okay. If you're saying it's 27 byte bin shell, then bin shell's available. We're not in a chroot. There shouldn't be any funny business there. What are we gonna do? Why is it crashing? Yeah, that's all fine. We can enter index into values, whatever. Index -99, end of file. So it's crashing when it tries to return. Can radar2 make sense of the leaked binary? No symbols, what do we do? Rodatu's not happy. This is a good song, by the way. I do like this song. Why is this crashing? Everything's fine until you hit the return. I swear to God, if there are stack canaries on, and we have to leak the stack to get the stack canary, and that comment lied about 64-bit and stack canaries, I'll be super pissed. I'm going to fire up IDA, see if IDA can make sense of this binary that we've leaked. I'm just going to turn the stream off for a second while I sort this out. What am I working on? I'm working on Smashtastic. I think so too, Barney. I'm wondering if that comment was just a huge troll in both respects. And I'll be quite upset if it was. Like, a blatant lie about Stack Protector being off when it's actually on is going to make me sad. Let's see how IDA goes with a corrupt elf file. Oh, there we go. It did well. It did very well. Okay, so here's the return. Oh, there's no stack canary check. Okay. That's good. There's no stack canary check. So now, why is this remote process crashing when we get to the ret. At least, yeah, there's no canary. I was going to be very upset if there was. So why is this crashing? What's going on? We can get to here as many times as we want. There's a variable as big as 1A8. Okay, so I think I was going up to 128. Yeah, it was. So that should be getting as far as the. You know what? I might just bump this up a bit. Cause YOLO. End of file. So yeah, we should be smashing as far as we need to. And we can get as far as entering an index of -99, and then it crashes sometime between enter an index, down to here. This here will be -99. Goes to here, leave ret. So there shouldn't be any nonsense going on. Yeah, there's no dereferencing of local variables that if I've smashed will cause a problem. Hang on, leave. That's going to be causing a problem if I've smashed EBP. x86 leave. 'Cause I think it does a pop EBP, move ESP EBP. Oh no. It does a move ESP EBP, pop EBP. That's fine. We should be fine with that leave there. I'm going to try something. It's XXDR and Smashtastic. Let's look for this. Let's see if that 7 means read write X, as we think it does. E551 51 E5. Yeah, so with our binary, which has an executable stack, we get a 7 there. Pretty sure this here is the NX bit. Well, the field that the NX bit powers. And the fact that we've got ours as 7 and theirs is 7 means that I'm pretty sure DEP is off. Pretty sure. Let's just try this out. Let's go that. Make clean. Make all. Yeah, then it's 6 with DEP being on. So I'm certain that the remote host has DEP off. Certain of it. What is going wrong? Is the shellcode just broken in some way? Or is the remote system breaking our shellcode? Do we need different shellcode? Shouldn't need to, Barney. It's bad character free, this stuff. Let's go and print pwn.asm, and we've figured out, we've done a leak of the shellcode in memory, and it looks identical, so there's no corruption going on. Yeah, there's no 00, there's no 0A in here, so it's not an encoding issue, it's not a bad character issue. And we've done an info leak and proven that it's where we think it is and it looks correct. So we shouldn't need to do that. Why would it be breaking? What if we spike say return pointer with the address of main? Just for funsies, see if it loops. Yeah, so we can spike the SRP with the address of main and the program loops. Problem with the shellcode. Or dep is on and my understanding of that flag in the ELF header is incorrect. But the program does, the briefing does say your shellcode will be useful. So what could be wrong with our shellcode? Our shellcode should be so far up the stack that the pushes aren't killing it. The shellcode shouldn't be corrupting itself. I'm gonna just punch out some Metasploit shellcode for something different. Cheers, Barney. Parks is off. Where's... Yeah, right on, Parks. Good to have you around. I'll see you next time, eh? Valid payload, Linux x86 exec. So I'll leave that out for now. Crash. Does it work locally? Yep. That's two of the shellcode that do not work remotely. Send line does append new line, and I think I want new lines. Yes, I'm sending commands, so I do want new lines there. Barney, segment permissions. Yeah, so I'm thinking 7 means RWX, but then like the stack permissions is stored in that special magical PF GNU stack, or PT GNU stack header with the flags there. So yeah, 7 should be RWX. What is wrong with our shellcode? Does bin shell not exist on the server and you need bin bash or bin dash or something? Like, I'm really clutching at straws now. No, SH has got to exist. Let's try that locally. Yeah, bash runs remotely. Crash. What is wrong with the shellcode? Or is dep on and I'm reading into things wrong? Like, I'm pretty sure it's an executable stack, that one. Yeah, yeah, totally. Good idea. Worth doing. Let's use Metasploit to punch it out. Let's do it locally. Yeah, good call. So that's locally, that worked. Remotely, crash. Or we've got an issue with how the things being served up, and stood out and stood in aren't actually wired up to the network. Which is possible. Crazy idea. Let me... shouldn't matter because I'm reinitializing buff, Barney. And that worked locally. Like if you go local, then you get the output of uname. Are you talking about commenting out the old stuff with this buff here, Barney? Because yeah, that buff there should cover it. What if there's an issue with how the remote process is actually started and stood out is not actually, when bin shell gets exec, well, if bin shell's getting exec VE'd, if we're getting stood out of this program when it does printfs, we should get stood out and stood in of the shell and of uname. Yeah, no worries, Barney. What could be going wrong? Unless certain syscalls have been disabled, things like the execv syscall somehow. Oh, what could this be? This is really irritating me now. Yeah, like stood out's getting flushed, so we definitely do see stood out. Why is the shellcode not? Do I just need real reverse shellcode? Worth a try. Yeah, it could be. Execute curl against a host you control. Infinite. I'm starting to think that maybe it's that syscall, the execv syscall, is being, I don't know what the Linux equivalent is, but like the BSD equivalent of being pledged away somehow, somewhere. But then again, Blue Pill said he did see some bin shell shellcode be used for the Nopstar challenge. Let's try the curl trick. Yeah, so curl happened locally. Let's go remote. That's a pretty quick end of file. I'm going to turn the stream off while I go check my website. Oops, didn't mean to do that. Yep, no, web server logs show just the one hit from my IP address. So curl did not trigger on the remote host. I guess it's time to try a real reverse shell. I'm just going to do a non-staged, plain old netcat style shell because I don't have Metasploit on a public box right now. Linux x86 shell reverse TCP. Let's grab that, chuck that up here. Okay, I'm going to turn the stream off again, just while I go try and catch a shell from myself and then catch a shell from them. Just 'cause I don't want to be showing IP addresses on stream. Oh, I probably should have set reverse host and stuff, shouldn't I? It's getting late. Lhost lport. Yeah, cool. Let me try this out. Okay, so I've got a shell for myself. Let's try remotely. No, no shell. Let's do a local one more time. Yep, reverse shell. So real reverse shellcode also works locally but not remotely. What else could be going wrong? Yeah, it's getting horrible, isn't it? No worries, Blue Pill. And there's nothing between this compare, because what we're doing is we're entering an index. We can put in whatever we want. We can put in negative 99. This happens, goes down here. Negative 99 gets compared to 63. Jumps if greater than to here, and then loops. We're not going to even go there. That loop's never gonna. Oh, enter an index class again. Okay, cool. That's useless to us. We go down here, compares to negative 99. It's negative 99. We jump inside the binary, leave return. Leave's going to do move, ESP, EBP, pop EBP. So at that time, EBP will be equal to the address of our shellcode. But that shouldn't matter because then the return will pass control straight to the shellcode. There shouldn't be any shenanigans with EBP going on. What does 010 think of the binary? Does it have an ELF parser? Nope. Is there a way to apply a parser that might help? What about just some file open, file read shellcode? What does PwnTools give us in Shellcraft? No, that's not what I wanted. That looks kind of neat. That'll probably tell us whether there's the ability to execute 2 bytes of infinite loop. Neat. T.send line. Pwn. It's a function, yeah? It's a function. Let's try that locally. Same fault. Is there a bad character in it? Ah, gotta assemble it. That'd help. Oh. Let's try that locally. Yeah, okay, infinite loop locally. Let's do it remotely. Huh. Okay, so we can make the remote and infinite loop. We just can't get a shell. Or a reverse shell. But we can get something. That's good. Dep is off. That's super promising. We got this. We can't get a shell, but we can probably just read a file. Where'd that come from? Is that Windows that dinged in my ear? Something dinged in my ear. Sorry, I'm just totally tired and totally loving reading through all this pwnlib shellcraft so I know what's there in the future. Like, I know there's going to be a file open, file read, file print, file close kind of thing, but I'm just curious as to what else there is. There's a lot in here. This is really cool. Wow. I'll have to read this another time. Do we just control F for file? pwn.shellcraft.blah.cat Python import pwn.that. It's not exec v-ing, is it? Push the path, blah blah blah. Yep, call sysopen. Send file. This should be legit. Let's try this. T.sendLine. Pwn.assemble. Pwn.shellcraft.blah blah 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 blah. So if we do that locally, then we get our own Etsy issue. Let's do this remotely. God damn it, what is wrong? We can infinite loop, but we can't shell, get files. Is it AppArmor, SE Linuxy kind of stuff? Like, can we only get certain files? Where's the briefing at? The briefing's in my channel description. Where's my channel description? Can we do that remotely? Nope. Is there a problem with the stack pointer at the time that we kind of get control over here? We can infinite loop. Can we do a push then an infinite loop? You can tell I'm getting desperate now. Because this inf loop totally worked remotely, yeah? Yeah, so the infinite loop works remotely. Let's go and look for push. Oh, let's just go pwn.assemble push oaks dead beef plus that. Is that locally? New line? Okay, so that infinite loop works locally. Remotely. That works, so we can push and then infinite loop. But we can't do anything useful. What else is in Shellcraft? This is just bizarre. This is beyond bizarre. I thought I saw echo in here before. Let's see if we can just send something just stood out. Work locally. Yeah, that worked locally. Work remotely. No. Is it a problem with stood in, stood out? Which wouldn't make sense because the binary uses, you know, stood in, stood out. What if we echo and then infinite loop? No, that breaks. No. Because my local system's 64, but the binary's 32. Nice work. We've also noticed that when you get printf to printf%p, it prints 32-bit stuff. Everything points to it being 32. And yeah, Blue Pill, my system is 64, but the binary is 32. And there's no issues. And no, in general, no, that's not going to be a problem. So if you assemble an echo, then an infinite loop, does it work locally? Yep. But even that doesn't work remotely. But we know the infinite loop does work remotely. What if we put an infinite loop before and after the echo? I'm sure it'll infinite loop remotely without echoing anything. Local. Yeah, locally it just infinite loops. Remotely, it just loops. Instead of the echo, we do a whole bunch of nops, then an infinite loop. Oh, we don't need to assemble those. Oh, that didn't work. That's interesting. That's really interesting. Oops. Okay, so a single knop's fine. 8 knops. Huh. I'm wondering if they've got like an IDS or something that's mangling hex 90. So what if we send that? We don't spike SRP. Oh fuck it, we can spike SRP. Print leak that. Dot encode hex. Let's do that after here. That's a pointer. What's that pointer doing there? Right, okay. Okay. Do I just have something happening remotely that's causing corruption way up the stack when I do my spike main SRP? Right, okay. Yep, nah, I'm on board now. I got this. I've totally got this now. I reckon. Let's comment that out. Let's yank that. Let's do that after the spike. Because I reckon the spike's causing corruption. And I was only ever doing the leak and check before I was doing the spike. Let's yank that. Let's yank this. And then I'll send negative 99. Does this work locally? I reckon we've got this. I'm feeling good. Yep, there's my local shell. Moment of truth. Here we go. Done. Wow. I made that so much harder than it had to be, and I failed at reasoning about flow and corruption. And I failed at checking that properly. I should have been doing my leak and check closer to the end of my exploit, not doing it before I then go and do this spike that then, based on, I guess, the remote stack layout, has a propensity to cause corruption of the shellcode based on where I planted it. Because I'm planting shellcode up the stack, I shouldn't be kicking off this huge spike and expecting it to be safe. So there we go, we're done. We're finally done. Wow. Where is Smashtastic? Oh, there's a lot of stuff on this box. There is a lot of stuff on this box. Let's go on base 64 Smashtastic. And steal it. Just in case I wake up tomorrow and want to dig through to find out what else I was making assumptions about. And I literally just swallowed a bug. That's awesome. Whew. Ah. I'm okay. If I pass out, call an ambulance, but I'm okay. There are these shitty bugs flying around, and I inhaled one. Let's go and steal this file, and go to bed. Yeah, there we go. Stole the file. Get that. Okay, cool. I will have a look at that later if I want to see what else I missed. But wow, we're done. That only took probably about 10 or 11 hours. That was made so much harder than it needs to be by me. I can still feel something going on. I'm going to take one more second, have a good cough. I'll be back in a sec. Rip. Okay, we're done. I'm so glad we finally got that. Yeah, time to progress can wipe that mother. Well, I was my own worst enemy there. I made some silly assumptions. I mean, good news is we learnt a lot. I learnt a lot. I learnt how to look at well, first of all, that's the first time I've dumped an entire elf using an info leak. That's a cool technique. I learned to use sensible variable names, or else you end up confusing them. But yeah, we had to play with RedTulipC, we had to play with info leaks, we had to play with DinElf, even though we didn't need it. We learnt to challenge our assumptions. What else did we learn with this one? They lied to me about down. They lied about the 64-bit, but we figured them out pretty quickly. I'm gonna have to sleep on that. We learnt a lot. It was good fun. I enjoyed it. I learnt quite a bit. I learned a bit more about how dynamic linking works. You know what? I'm not going to go through what we learnt. I'm going to bed. Thank you everyone for sticking around with us. That was a mission, but I had fun. I hope you did too. Hope you learned things. If you've got any questions, queries, concerns, I'm not answering them tonight. It's 1 o'clock and I'm going to bed. If you've got any questions, queries, concerns in the coming days, hit me up on Slack, hit me up on Twitch, not Twitch, Twitter, what have you. Yeah, thanks a lot everyone. I'll catch you next time.